You need to solve the game by using a dominance concept. Let us go to the solution. First step one, you need to apply row dominance. That is, you need to check with respect to the row. If you compare first and second row, 5, 6, 5 is greater, 4, 6, 6 is greater, it is equal, 8, 7, 8 is greater. That is, none of the row, when you compare with respect to first and second, is not leading. If you compare first and third, 2, 6, 6 is greater, 4, 7, 7 is greater, 3, 9, 9 is greater, 8, 8 equal, 4, 7, 7 is greater. That is, first row is less than or equal to third row. That is one case. Then if you compare other possibilities, first and fourth row, 2, 4, 4 is greater, 4, 2, 4 is greater. That is, when you compare first and fourth row, none of the row is leading. Then if you compare second and third, 5 or 6, 6 is greater, 6, 7, 7 is greater, 3, 7, 3, 9, 9 is greater, 7, 8, 8 is greater, 8, 7, 8 is greater. That is, if you compare second and third, none of the row is leading alone. Then second and fourth, 5, 4, 4 is 5 is greater, 6, 2, 6 is greater, 3, 8, 8 is greater. That is, when you compare second and fourth, none of the row is leading alone. Then next 6, 4, 6 is greater, 7, 2, 7 is greater, 8, 9, 9 is greater, 4, 8, 8 is greater, 3, 7, 7 is greater. Therefore, the column 4 is less than the column 3. That is, row 4 is less than row 3. That is, elements of fourth row is less when compared to the row 3. Therefore, lower value, that is the row 1 and row 4 is deleted because lower value row. When you delete first and fourth, is first and fourth, then left out strategy is second and third. That is, left out strategy is second and third. Here you have to write second and third. And with respect to column B, you have 5 strategy. You need to copy down same. It is 1, 2, 3, 4, 5. This is for player B. This is for player A. Then the elements corresponds to strategy 2 and 3. 5, 6, 3, 5, 6, 3, 7, 8, 6, 7, 9, 6, 7, 9, 8, 7. Then you have to apply step 2. That is column dominance. That is, you need to check with respect to the column. That is, when you check with respect to the first and second column, 5 or 6, 6 is greater, 6, 7, 7 is greater. That is, the column 2 is greater than first column. Then again, you check with the other possibility, first and third, 5, 3, 5 is greater, 6, 9, 9 is greater. That is, first and third, if you compare the first and third column, none of the column is leading alone. Then 5, first and fourth column, 5, 7, 7 is greater, 6, 8, 8 is greater. It is the column 4 is greater than first column. The next fourth, first and fifth column, 5, 8, 8 is greater, 6, 7, 7 is greater. It is the column 5 is greater than first. Then we will check with respect to other possibilities from second and third, 6, 3, 6 is greater, 7 and 9, 9 is greater. It is not possible. 6, 7, 7 is greater, 7, 8, 8 is greater, that is element fourth column is greater than second column. Then next, for second and fifth, 6, 8, 8 is greater, 7, 7 is equal. The column 5 is greater than or equal to second column. Then if you compare third and fourth, 3, 7, 7 is greater, 8 and 9, 9 is greater. It's not possible. Then third and fifth, 3, 8, 8 is greater, 9, 7, 9 is greater. Then last fourth column and fifth column, 7, 8, 8 is greater, 8, 7, 8 is greater. That is, these are the possibilities where the second column, fourth column, and fifth column is leading. Therefore, second column, fourth column, and fifth column. Again, fourth column and fifth column is repeating, and hence second column, fourth column, and fifth column is deleted because higher column element. That means if you delete second, fourth, fifth, that is second. Then next you have fourth, and you have fifth. The left out strategy is 1 and third. Left out strategy is 1 and third strategy. To copy down the left out strategy for player B, we have 1 and third strategy, and for player A, the left out strategy is 1 and second and third. Here you are right, player A, and the elements is 6, 5, 6, 5, 6. For third strategy, 3, 9, 3, 9. Since the size of the matrix is reduced to 2 cross 2, we can apply saddle point concept. Then here you write row minima out of 5, 3, minimum is 3. Then 6, 9, minimum is 6. Out of this minima, maximum is 6. Here you write maxi min. The next year you write as usual column maxima. Out of 5, 6, maximum is 6. Out of 3, 9, maximum is 9. Out of this maxima, minimum is 6. Here you write mini max. Since maximin is equal to minimax, that is the maximum is 6, minimax is also 6. This implies game with saddle point. Therefore, strategy for player A, the corresponds to maximum value. The strategy is 3. Here you have tried 3. For similarly for player B, this corresponds to minimax value. The strategy is 1. The strategy is 1. Then you need to write the value of the game. Value of game B equals intersection of these two elements. That is element 6. That is the value of the game. You need to compare as usual step 1. That is row dominance. Step 1, row dominance. First we check with respect to first and second. 20, 25. 25 is leading. And 15, 14, 15 is leading. It is 1 and 2 is not possible. 1 and 3, 20, 40. 40 is greater. 15, 2, 15 is greater. 1 and 3 also not possible. 1 and 4, 25, 20 is greater. 15, 4, 4, 15 is greater. 12, 11, 12 is greater. 35, 0, 35 is greater. That is the fourth row is less than first row. It is one condition. Then next we'll check second and third. 25, 40, 40 is greater. 14 to 14 is greater. Second and third is not possible. Second and fourth, 25, 5, 25 greater. 14, 4, 14 is greater. Late 7, 11 is greater. Second and fourth is not possible. Third and fourth, 45, 40 is greater. 2, 4, 4 is greater. There is none of the row is leading alone when you compare other possibilities. There is only one possible is fourth row is greater than fourth row is less than first row. Therefore, lower value, that is fourth row, is deleted. When you delete fourth row, the left out strategy is 1, 2, 3 for player A, and for player B, the left out strategy is 4. 4 strategy 1, 2, 3, 4. 3 and 4 is 1, 2, 3, 4 strategy. Fourth row is deleted because it is having a lower value. Then left out element is 25, 20, 15, 12, 35, then 25, 14, 8, 10, 40, 2, 19, 5. Then we will apply step 2 for this reduced matrix. It is for step 2, column dominance. When you apply column dominance, you will check with respect to first and second. 20, 15, 20 is greater, 25, 14, 25 is greater, 42, 40 is greater. This first column is greater than second. Then we'll check other possibility, second and third. 20, 12, 20 greater, 25, 8, 25 is greater, 40, 19, 40 is greater. It is the first column element is greater than third, and then second, right here only. And is the element of first column is greater than first and second column, first, second and third column. Then next, first and fourth column, 20, 35, 35 is greater, 25, 10, 25 is greater. That is combination of first and fourth column is not possible. Then we will check with second and third column, 15 and 12, 15 greater, 14, 8, 14 is greater, 2, 19, 19 is greater. That is second and third is not possible. Second and fourth, 20, 15, 35, 35 greater, 14, 10, 14 is greater. Then we will compare third and fourth, 12, 35, 35 is greater, 8, 10, 10 is greater, 19, 5, 19 is greater. There is a other possibility is not possible. There is only strategy only possible that is only possible is first column is deleted. When you delete first column, the left out strategy is second, third, fourth. Second, third, fourth, and strategy with respect to A is 1, 2, 3. 1, 2, 3. And you have second, third, fourth. Second, third, fourth. Here you write first is deleted because of a higher element. The left out element is 15, 14, 2. 15, 14, 2. 12, 8, 9. 12, 8, 19. 35, 10. 35, 10. And you have 5. Then step 1 is row dominance. Step 2 is column dominance. Then after applying step 1 and step 2, the order of the matrix is 3 cross 3. Order of the matrix, we got 3 cross 3 matrix, but we need to reduce to 3 cross 2 cross 2 matrix. and then we'll apply step 1 again. As per the dominance rule, we have 4 steps. That is step 1, row dominance. Step 2, column dominance. Step 3, we have modified row dominance. But here, after applying row dominance and column dominance, if the size of the matrix is not reduced to 2 cross 2, we will apply again step 1. That means we will have step 1, there is row dominance. We will check, is there any possibility with respect to row? For this reduced matrix, if you check with respect to the row, 15 to 2 is less, 15, 14, 14 is less, 12, 8, 8 is less, 35, 10, 10 is less. That is the second row element is less than first row. Then if you compare the first and third, 15 to 2 is less, 12, 19, 12 is less. This first and third is not possible. If you check second row, 14 to 2 is less, 8, 19, 8 is less. That is none of the row is leading or dominance with respect to any of the row. The lower value is second row is deleted because it is a lower value. Once you delete second row, the left out strategy is 1 and 3 for player A, and for player B, the left out strategy is 2, second, third, and fourth. The elements here 15, 12, 15, 12, 35, 2, 19, 5. It is for player A. For this matrix, since the order of the matrix is 2 cross 3, again you have to apply column dominance. Modified step 3 will apply only when none of the row is dominant. If none of the row is not dominant, then only will apply step 3. Then next we'll apply step 2 for the above matrix. We will apply step 2 for the above matrix. That is column dominance. There is in this table, if we compare second and third column, 15, 12, 15 is greater, 2, 19, 19 is greater. That is not possible. 15, 35, 35 is greater, 2, 5, 5 is greater. That is elements of fourth column is greater than second column. Then we'll check and we'll check third and fourth. 12, 35, 35 is greater, 19, 5, 19 is greater. That is the other possibility is not possible. The only possibility is element of fourth column is greater than second column. Therefore, fourth column is deleted. That is fourth column. You need to delete. Left out strategy for player B is second and third. Second and third. For player A, left out strategy is 1 and 3. 1 and 3 for player A, and element is 15 and 2, 15, 2, 12, 9. Since the size of the matrix is reduced to 2 plus 2, we can apply saddle point concept. That is row minimum. Out of 15 and 12, minimum is 12. 2, 9, minimum is 2. Out of this minimum, maximum is 12. Here you have to write maxi min. Similarly, here you have to write column maxima. Out of 15 to maximum is 15. 12, 9, maximum is 12. Out of this maxima, minimum here, this is 19. Here you have 19. Here 15 to maximum is 15, 12, 19, maximum is 19. Out of this maximum, minimum is 15. Here you have to write mini max. Then next, you have to write since max min is not equal to mini max. That is maximum value is 12, mini max value is 15. This indicates game without saddle point. Game without a saddle point. Then next, you need to consider the probabilities. We need to consider the probabilities with respect to the strategy of player A and player B. With respect to player A, strategy is 1 and 3. Therefore, let x1, x3, and with respect to player B, second and third is y2 and y3, or the probability for the player A and B of strategy 1, 3, and 2, 3, respectively. Then next, to find x1 value, since you're finding with respect to x1, if you close, you will get 19 minus 2, 19 minus 2 divided by diagonal element, we need to add, that is 15 plus 19, we will get 34 minus 12 plus 2 is 14. We will get 17 divided by 34 minus 14, we will get 20. Therefore, x3 is nothing but 1 minus x1. If you substitute, you will get 3 by 20. This is for x3 value. Similarly, if you find the value for y2, since you are finding with respect to y2, if you close, you will get 19 minus 12. 19 minus 12, denominator will get 34 minus 14, 7 divided by 20. Therefore, y3 is nothing but 1 minus y2. You will get 13 by 20. This is y3 value. The next value of the game B is given by diagonal element. We need to multiply, that is 15 into 15 into 19. It is will get 285 minus 2 into 12 is 24, all divided by denominator will get 34 minus 14. Then if you calculate 285 minus 24, we will get 261 divided by 20, or if you calculate, we will get 13.05. We get 13.05. The next you have to list in the table. You list it in the table. It is player A, player B. For player A, the strategy notation is given 1, 3, and the probability is x1, x3, x1, x3. And for player B, the strategy is second and third, probability is y2 and y3. And elements for x1 value, 17 by 20, and for x3 value is 3 by 20. Then for player B, the value of y2 is 7 by 20, and for y3 is 13 by 20. This is the strategy the player A and player B must use to win the game. Third graphical method. It is graphical method is applicable whose payoff matrix must be 2 cross M type or N cross 2 type. That is, graphical method is applicable only when the payoff matrix must be 2 cross M type or N cross 2 type. That is, either player A or player B must or should be two strategy. That is, either the player A or player B should have only two strategy. The value of M and N must be greater than or equal to 3. That is, the value of M and N must be greater than or equal to 3. Then next, we have two cases. There is case 1. Case 1, that is 2 cross M type. Here, player A, we have two strategy, whereas player B is having M strategy, where the value of M is greater than or equal to 3. The next case, case 2, N cross 2 type, N cross 2 type. Here, the player A, B is having two strategy, whereas the player A is having N strategy, where the N value is greater than or equal to 3. That is 2 cross M type. We call it as a row player. Row player, whereas N cross 2 type, we call it as a column player, because he is having only two strategy, whereas for row player he is having a two strategy. Let us go for the problems on graphical method. Solve the game. Solve the following 2 cross 3 game by graphical method. By graphical method, and they're given 2 cross 3. First, second, third, and they're given 1, 3, 11, 1, 3, 11, 8, 5, 2, 8, 5, 2 for player A. Let us go for the solution. Since player A is having two strategy, therefore the given problem is of 2 cross M type. It is since the problem that given only two strategy with respect to player A, and then the given problem is of 2 cross M type. Once you identify the type of problem, then we will construct the graph according to the given data. Since the player A, they are given two strategy, just to draw two lines, just to draw a two vertical lines with appropriate distance. This distance can take appropriately. And for player A, they are given 1 and 2. Here you write player A, and strategy for player A is 1 and 2. Here you write 1 and 2. And if you look at the elements in the matrix, the least element is 1, highest element is 11. So that I can start with 1 directly. Say if I start with 0, say it is 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Similarly, on strategy 2, whatever the scale you have taken with respect to strategy 1, the same scale you need to take. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You need to draw this drawing in a graph sheet. Then after drawing the numbers on the graph sheet, then next you need to locate all these values. For player B, we have 1, 8. That is for strategy 1. We have 1 is 1, and we have 8 for strategy 2. We have 8. We need to join these 2 points. If you join these 2 points, that line represents with respect to player B. There is here you rotate for strategy 1. This for player B is 1, 8. Is 1, 8 for player B. Similarly, other elements 3, 5. Here you have 3. Here you have 5. You join, locate strategy 2. And 11, 2. You have 11. Here you have 2. Then if you join it, you'll get in this way. This is for strategy 3. Then after locating all the strategies on the graph sheet, you need to check since the problem is 2 cross M type. Therefore, select the lower boundary. That is, you need to select the lower boundary. That is, lower boundary is this is the boundary. That is, you need to highlight all the corner point or intersection point. Here we get one intersection point. 1, 2, 3, and 4. This is the lower region, or we call it as a lower boundary or lower region. Out of this lower region, you need to select the maximum. It is here. You have 1, 2, 3, 4 points. Out of these 4 points, the maximum is at this point. Here you have tried P max. That is the maximum point. Corresponds to this point. The strategies are second and third. Therefore, you need to take out the strategy 1. That is in this problem. I will repeat again. After shading the lower region. Since the problem is of 2 cross M type, we need to select the lower region. After selecting the lower region, we need to get all the intersection and corner points. Corner point, we have 1, 2, 3, 4 corner and intersection point. Out of these 4 points, maximum is at this point, corresponds to point P, is corresponding to P max, corresponds to P max. The strategies are strategy for player B, or you have second and you have third. It's second, third. Therefore, strategy 1 is deleted. You need to delete the left out strategy. Then the table we will get the table we will get the second and third for player B. For player A is as usual 1 and 2, and the element is we will get 3, 11, 5, 2, 3, 11, and you have 5, 2. Five, 2. 11, 2, and 5, 2. Then next, since the order of the matrix is reduced to 2 cross 2, we can apply the saddle point concept. That is row minimum. That is minimum is 3, maximum out of this minimum maximum is 3. That is here you write maxi min. The next similarly, you have to find column maxima. Out of 3, 5, maximum is 5, 11, 2, maximum is 11. Out of this maxima, minimum is 5. Here you have to write mini max. Since maxi min is not equal to mini max, there is maximum value is 3, mini max value is 5. Therefore, game without saddle point. Game without saddle point. The next you need to consider x1, x2 and y2, y3 for the player A and B of the strategy 1, 2 and 2, 3 respectively. Then after getting a probability, you need to calculate the value for x1, x2, x3, x1, x2 and y2, y3. It is same as that of previous problem. We have what is x1, calculating x1, 2 minus 5. 2 minus 5 divided by 3 plus 2. 3 plus 2 is 5 minus 5 plus 11 is 16. We'll get minus 3 divided by 16 minus 5 will get minus 11, or we'll get 3 by 11. The next x2 value 1 minus x1. X1 you will know 3 by 11. 11 minus 3 will get 8 by 11. The next similarly we need to find the value of y2. y2, you are finding 2 minus 11. 2 minus 11 divided by 5 minus 16. This denominator will get the same. Then 2 minus 11, it is minus 9 by 11 or 9 by 11. Similarly, y3 is nothing but 1 minus y2, and we will substitute 11 minus 9, we get 2 by 11. The next value of the game, B is given by 3 into 2, it is 6, minus 5 into 11 is 55. Divided by denominator 5 minus 16, you get minus 49 divided by minus 11, or get 49. Solve the game by graphical method. And just I will copy down the problem. They are given player B is having two strategy, B1, B2, and for player A, you are having four strategy, say A1, A2, A3, and A4. This for player A, and the elements then given 1, minus 3, 3, 5, minus 1, 6, 4, 1. Then next we'll go for the solution. The problem given is n cross 2 type, that is player B is having two strategy, whereas player A is having n strategy, and they're given n value as 4. That is, they're using a 4 strategy for player A. Let us draw the graph for the given data. We have two strategy. Just you draw two vertical line with the appropriate distance on the graph sheet, and with respect, since it is a 2 cross n type, n cross 2 type, you need to start with the player B. There is the strategy B1, B2. Here you represent B1 and B2, and here you write player B. In previous problem, we written as player A because it is 2 cross m type, but here the problem that given is n cross 2 type, and hence you have to write player B, and respective strategy that given notation as B1, B2, you need to write B1, B2. And here in this table, if we check out, the least value is minus 3 and maximum value is 6. So that I can start with minus 3, minus 3, minus 2, minus 1, 0, we have 1, we have 2, 3, 4, 5, and 6. In the similar line, you need to construct on B2. This we have minus 3, minus 2, minus 1, we have 0, we have 1, we have 2, we have 3, 4, 5, and 6. Then we will indicate 1 minus 3. For B1, it is 1 minus 3. 1 is here, and for B2, it is minus 3. Minus 3 is here. You need to join these two lines, these 2 points, and the respective strategy is A1. Here you have to write A1. Similarly, next 3, 5. 3 is here, 5 is here. You need to join. Name it as A2. A2. Then minus 1, 6. Minus 1 is here, plus 6. Then we'll join these 2 points. You name it as A3. The last strategy is 4, 1. 4 is here plus 1. Then we'll join. That is A4. Then after drawing all these points, since the problem is n cross 2 type, since the problem is n cross 2 type, therefore select the upper region and identify the lower point, that is P minimum. That is since the given problem is of n cross 2 type, we need to select the upper region and identify the lower point, that is P minimum. This upper region is you will get this region. That is, we need to start from the corner point. One intersection point you will get. Then you have to proceed in the same direction. You will get one more point. Then we will get this point. Then after identifying the upper region, here you have to write upper region. After writing the upper region, we need to select the minimum point. In this case, you get minimum point at this point. Here you have to write P minimum. At P minimum, at the point P minimum, strategy for player A is corresponds to this. This strategy for player A is A2 and A4. A2 and A4. Therefore, strategy A1 and A3 are deleted. That is the left out strategy we need to delete. Then we will get the order of the matrix. We will get here you have B1, B2 for player B, and for player A corresponds to P minimum. Strategy left out is A2, A4, A2, A4. We need to delete A1, A3. A1, A3 you need to delete. Corresponds to A2, 3, 5, 3, 5. Corresponds to A4, 4, 1. The next, since the size of the matrix is reduced to 2 cross 2 matrix selection, out of this minimum maximum is 3. Here you have to write maxi min. Similarly, with respect to column maxima, out of 3, 4 maximum is 4. Out of 5, 1 maximum is 5. Out of this maximum, minimum is 4. Here you have to write mini max. The rest of the procedure will remain same. Since maximum is not equal to minimax, that is maximum is 3, is not equal to 4. This indicates game without saddle point. Game without saddle point. The next you need to consider the probability. Let corresponds to A2, A4. The probability is X2, X4, and corresponds to B1, B2. Probability is Y1, Y2. You write all the wordings. It is X1, X2, and X2, X4, and Y1, Y2 are the probabilities. Or the probabilities for the player A and B of the strategy of strategy A2, A4, and B1, B2 respectively. Then next you need to find the value of x2, x4, y1, y2. We will proceed in the same direction. We will get the solution for each probability. That is, you need to find for x2. Here you write x2 equals, since you are finding with respect to x2, 1 minus 4 is 1 minus 4 divided by diagonal element. You need to add 3 plus 1 is 4 minus 9 is 4 plus 5 is 9. Then 1 minus 4 minus 3 divided by minus 5, or you will get 3 by 5. Then next you have x4 is nothing but 1 minus x2. You know the value of x2. If you substitute, you will get 2 by 5. Then next y1. When you are finding with respect to y1, 1 minus 5 divided by 4 minus 9, you will get minus 4 divided by minus 5, or you will get 4 by 5. And y2 is given by 1 minus y1, or 1 by 5. Then next, we will write the value of the game. Value of game is denoted by capital V, and it is given by diagonal element. You need to multiply 3 into 1, which is 3 minus 4 into 5, it is 20. Denominator will remain same, which is 4 minus 9. 3 minus 20 is minus 17 divided by minus 5, or you will get 17 by 5. Then next, you write the probabilities in a tablet or manner. In a tablet, that is here you write player A, player B, and for player A, the strategy is A2 and A4 as per the given notation, and the probability is x2, x4. Here you write x2 and x4. Similarly, for player B, the given as B1, probability is y1, and B2, probability is y2. And the value for x2 is 3 by 5. Here you write 3 by 5, 2 by 5. For player B, y1 value is 4 by 5 and 1 by 5. So this is the solution for the given problem. That is, the player must use a mixed strategy to win a game. And